Possibly, yes, okay. So welcome to my talk, How to Get a Free Dinner at JSday 2018. Why am I talking about this? Well, as you can see, my friend Cesare, little did he know that I would get the wrong bus at 2018, and that was my first ever tech conference organized by the GRUSP here in Verona, here at Hotel San Marco. And at that point, you could see that I was really wearing the attendee badge over there, but Cesare just trusted me and I was going around Verona. They had cameras all over the place. I was like a model just roaming around trying to do the best, and I actually got free dinner out of it. So that was just a little bit of a reason why I really wanted to participate at JSday at some point. It took me a few years, but then at the end, I don't know why still, but we managed to get that done. But the real talk today is the event loop fairytale. Now, the event loop fairytale is called like this because I believe that most of the times as tech people, we get to talk about very technical details in manners that don't allow us to fully understand and to fully delve into the beauties and the intricacies of technology, right? We get that library, we get those pages done, and that's it. Maybe there are some open source developers or lib developers, even not open source out there, that are having lots of fun doing it, but not a lot of people get to actually enjoy what's going on behind the curtains. And what is going on behind the curtains really is the pure gold that as developers we should be allowed to enjoy. So let's talk about the history, and it was history. What you can see on the screen is what I would like to refer as the dragon block. In a time far away, because it's a fairy tale, we would have all these amazing and incredible knights fighting to ensure that everyone of their population would be allowed to enter the castle, go to the bakery, do whatever task they had in mind, really, in a manner that would be unblocked. But how could they do it? Imagine you were living, I don't know, in Javaville or the Python kingdom for whatever reason, right? How could they do that? In the C++ DOM, right? How could you do that? There was no notion, not an actual in-language notion of asynchronicity per se. They had to build around it. Even with the most amazing thread, you don't have the concept of asynchronous, because you've got one thing, and that one thing is running something, and that something, as fast as it is, it's not doing it in parallel with something else, until you add superpowers to it. But that's not the fairy tale about those superpowers yet. We're still talking about our friends from Pythonville, from Javadom, and all those wonderful villages, right? And what they did to fight these red dragon blocks was that they invented their own magic. And so they invented an order, the Knights of the Thread. And the Knights of the Thread were valorous knights who would fight all those dragons that would try to block the joyful life of those very smart programming villagers. How would they do that? Well, they had their own methods, right? If we think about Javadom, they had invented an inner order inside their castles, the Order of Nio, and the Order of Nio allowed them, and you can check that on Google, allowed them to actually do some asynchronous work inside the language to allow for kind of non-blocking operations. But you still need a lot of resources for that. And if we think about the kingdoms of the many seas, right? They had to use what is known system-wide as POSIX threads to allow for asynchronous operations to run in parallel and concurrently, right? And then we had Python. Python had invented a strange, very weird magic called async.io that took a little bit of a while for the villagers to get used to it, but at the end, they were also able to use this kind of magic. The problem is, we're all talking about outer orders, something that comes from the outside to help the main language, which is the inside of the castles, the safe walls that make sure that no villager gets attacked by the red dragon of block. So, when that happened, for years and years, millennia, if you think about that, since we're in tech, right? What happened is that they started to notice about the existence of something that they never heard before, something that would just defend its villagers without any necessity from outer orders to come on the inside of the castle walls. And they discovered the existence of this beautiful lens of the promise, and the pun is very intended there. The lens of the promise as was discovered by these explorers and scholars, had a very wonderful castle sitting in the middle, which was the castle of the single thread. And everyone was amazed by that. Everyone was asking their questions like, how is that even possible? We've known about threads for years, millennia really, eons even. But we've never imagined how we could use that single one thread to ensure the safety of all our task villagers. How were they doing it? Well, the word quickly spread, and the castle of the one thread didn't really need armies to defend it. And that is because they had a very magical, unintuitive at some point, fairy that was very benevolent and was protecting the entire castle of the one thread and the land of the promises. And that was the fairy of the event loop. So, the fairy of the event loop was gracefully dancing between technologies to ensure that everyone would have their amazing time to live in this castle of the one thread, to live in the village of the Node.js fairytale. And all of these villagers, which we're going to call tasks in a very unfashionable way, had the opportunity to just run without worrying too much about whether they were taking too much energy, whether they were taking too much space, whether at some point or another they had to exactly work as expected. In this land, villagers could just go on and about. Want some bread? Sure, take bread. Oh no, sorry, the bread is not ready yet. Yeah, I'll come make it back later. I'm going to the blacksmith now. That's how the villagers really acted when they were there. It was a really fun way of working, really, a new philosophy in a kind of way. In fact, lots of wizards, let's call them, from other castles like Java, C#, and so on, started to migrate away from those languages or orders and started to become people of the land of promises. And that would be programmers coming from other languages. So, how did that work really? Well, we just mentioned that, but the inhabitants, which is what we're calling the tasks, essentially would just roam around. And they knew that to exist in this land of promises, they had to ensure to themselves and to all the others that were working alongside with them that they would never block anything. That was the promise. You want to be part of the village of promises, you want to be part of the knights of the single-threaded castle, you got to promise that you're never blocking anything. That's it. That's the only thing you got to do. Each villager was kind of in its own part of this Node.js instance, this engine that would ensure that everything would run smoothly. But before we delve into a little bit more of an intricacies, let's say hi to our friend, Jack Smallpouch, whom is living on a quest because he will want to come back at some other point as an adventurer and as the rogue that he or they are to ensure that we have all the knowledge that we have. So remember our friend Jack Smallpouch for a later time. Who was on top of the castle of the one thread? Can anyone imagine who's the big boss on top of the castle? V8, yeah, sure, kinda, sure, we're getting there, a little bit more technical. It would be Sir Colastack. Sir Colastack, as you can read, he was and still is, the valiant knight of asynchronous, the defender of the promised lands, first of his name, liberator of, no, that was entirely other thing, but you get where I want to go, right? So, my friend and your friend, Sir Colastack, would work alongside the fairy of the event loop to ensure that everything would work as smoothly as we can imagine. But how was that working? Well, everything was working because they had internal rules between each other. They knew that to make everything work as expected, they needed to follow up on some rulings. One of them would be that Sir Colastack only knew to do very well one thing. And that one thing was the magic of LIFO, last in, first out. Amazing. I know that I don't even know like if they found it like in a very big tome, you know, with all the dust on it and started learning about last in, first out principles. But that was the idea. The fairy would take all the tasks, make sure that everyone would be happy with their outcomes and with their callbacks and so on. And Sir Colastack would be there, ensuring that whenever a task was actually supposed to run, or the callback thereof, he would take that, make it an execution context, execute it, and then return whatever value was supposed to be returned. That was the idea. They would work together and form an alliance to ensure that we wouldn't need to think about anything anymore. It's like Wizardry 101. We're just wizards without thinking too much about the idea of parallel or concurrent programming, really. So that was very strong on their side. And they would do it because at the heart of the village, the villagers, the tasks, were instructed that they had to participate in this fair of the loop to ensure that they would never be blocking. And at that point, they knew what to do. They knew exactly how they should behave. When a task, in its very synchronous way, would know that it was synchronous and needed to be so, they would go to the fair, talk to the fairy mother, and to circle a stack and tell them, okay, I'm running now. I need stuff right now. It's very important. And it's immediate execution right now. And it would happen, you know. Synchronous programming is still a thing. It didn't go away with Node.js, no matter how much fairytale you can put upon it, no matter how novelty that is. Synchronous programming is still a thing, and it's going to be a thing forever, I guess. But what the other task would do is that they would be asynchronous in their own nature. So what is the thing about asynchronicity that really we will never or almost never know about? Can anyone tell me the single one nature of asynchronous that we can never know about? Would you like to try? Would anyone like to try? You can guess about the asynchronous nature, but you can never know exactly. Yes, the when, exactly. And that was it. I guess that's why it's called the random promises, really. You're promised that at some point you're getting something out of it. Do you know when exactly? No, you don't. You don't. Even if you're very well aware of the technical details of Node.js, like with timers, for example, right, with intervals or timeouts, what you have is an exact notion of when that thing is going to be on the stack. You don't know when that thing is going to be run on the stack because you don't know what is on the stack at that point, right? You can have an idea around it, but you don't know exactly if that 1 millisecond timer is exactly going to be 1 millisecond. And in fact, it's never going to be 1 millisecond. It's going to be some other nano time on top of that millisecond. But aside from that, those tasks knew exactly what to do. They needed to accept their nature of asynchronous and join the fairy in the village, and the fairy would tell them, okay, you want to be in the call stack of circle a stack? Sure. You got to depart on a very nice quest. And this very nice quest would take them to the desert of asynchrony. Now, who would be and go on a quest to the desert of asynchrony? Well, I'll start with an example, right? Promises, for example, in the language itself, would definitely go in the desert of asynchrony. At some point after a while, they would be either resolved or reject, but promises would be there. Can anyone tell me of any other operations that could go to the asynchrony desert? Could you tell me of one? What kind of system call could be very in need of asynchronous to avoid blocking the something? Observability could be, but I was thinking something simpler, right? Okay. You want to tell me another one? Timeouts, sure. Anyone else? It's a very simple one. The first I/O, yes. Those things, those are the real blockers. I/O operations. You get a text file, a JSON, something that is megabyte worth of thing, and you're blocking the entire thread forever. That's it, right? Do you want to block the thread? What is the number one rule? Tell me the number one rule altogether. Come on. Never block the thread. That is not Node.js. It's a loop, right? So that is the rule, right? Never block the single thread, even though it's kind of a lie. But this is what they exactly knew. If you are an I/O intensive operation, if you are a callback, if you are a timer, if you are whatever you are, but not synchronous, that's exactly where you want to be. You want to go on the desert of asynchrony. No tasks were mistreated in the desert of asynchrony, just to ensure that everything is running smoothly. And once they've been through the desert, they would reach the forest of the thread pools. Now, in the forest of the thread pools, what they would do is they would get there, and they would have some very amazing, fantastic friends waiting for them to do what? Well, to get accepted. And who would be those friends? Those friends would be the libuv elves. Now, this I must say, because we're not specifically talking about Node.js event loop, but in a rather more generic way. In this case, we're talking definitely Node.js. That's libuv's Node.js thing. If it was JavaScript, it would be another system-wide API. I think it's either libev or libevent, I don't know. But every runtime has its own thing. In this case, take it for the Node.js thing, okay? So, the libuv elves, very nice people, or elves. They would be the owners of the libuv secrets. Now, the libuv secrets were so that whenever an asynchronous task would get to the forest of the thread pools, those elves in the libuv forest would know exactly what to do with them. And how so? We said that JavaScript and Node.js is a single-threaded language, and that is why we should never block the thread, right? Well, it's a lie. You've always been lied to, right? Because JavaScript, the loop of JavaScript, and the synchronous nature of JavaScript is running on a single thread, which is smart enough to know when it should not block itself. So you, as a wizard programmer, should also know when to not send stuff on the single thread that takes care of the running loop, right? Because you are very aware of asynchronicity of the asynchronous nature of programming, what you do is you get those callbacks, you get those very natural async awaits and things and promises running, and you send them to our friendly elves, and those friendly elves know of the existence of system-wide threads. So as programmers, you also have the opportunity to kind of enlarge the forest as much as you like, but each thread needs some memory and some processing power, so be sure that you put the right number in place. But ideally, in Node.js, for example, you start with 4, I believe. That's the pool thread. In Node.js, I think it's 4. If it's not, you know, it's another number, an integer somehow. But the idea is that you have those threads, and the synchronous tasks are taken. The fairy sends them to the desert. They go through, found by libuv elves, and libuv is smart and kind enough to take those very nice tasks for you without you noticing anything, because at that point they have the asynchronous nature that makes them do that exactly. They end up in one of those threads in the thread pool, which might have already been spawned, and that's the smart part of it. Threads are not respawned on time every time. If they exist already, libuv elves know exactly what to use because free threads, so let's just reuse them, right? And so that makes Node.js, in this specific case, a little bit faster than other languages that behave kind of in the same way, other runtime that behave kind of in the same way. And once the libuv elves are done with that, what we get out of the asynchronous nature of this is some synchronous nature that we are not executing. And those are the callbacks. Once we are done running the asynchronous tasks, libuv makes sure that those tasks are sent to the thread, whatever thread that is, and we get back the execution that we must then run somewhere else. Okay? That is when the synchronous nature of the task reveals itself and becomes once more part of the call stack at some point. Because once libuv is done, they give back the callback. The path, the tasks make their way back to the city very happily, and they join the queue once more. And once they join the queue, they are ready to be taken upon by circle a stack, which is very firm in its nature of synchronous calling. And that is exactly how it works. That is how the non-blocking nature of the land of promises work in a fairytale manner under the hood. They join the queue once more, circle a stack takes them in the order of arrival at this point. So it's not necessarily true that when those tasks are delivered at the start, that they get back in the exact same order, right? Some reading of a file might take 2 minutes, some callback might take 2 seconds. It's, of course, normal that the 2 seconds one is gonna be queued back in before the reading of the file. It's pretty normal. It's the asynchronous nature of the tasks, exactly. So that's how it works in a little way. What we should be aware, though, is the fact that the menacing dragon of blocks still exists. It's not that the Lands of Promises is without dragons or monsters. There's definitely monsters and dragons there. And I think that as JavaScript developers, most of the time, we don't really care too much about them. But also, we should not be afraid of them. It's not that we need to tame them, it's that we need to respect them. If you know your language, if you know the intricacies of the language, you know exactly what you need to do to make sure that those dragon blocks are not destroying your Lands of Promise. Sure, they could roam around. If they're not destroying anything, it's a beautiful creature to see. I would surely love to see a dragon, as long as it doesn't spit fire on me, right? So that's kind of the trick. Never underestimate, but surely understand what those blocking things could be. If you're trying to read from a 2 megabyte file in a synchronous way, you're blocking the event loop for, I don't know, 1 minute, 2 minutes. That is a lot of time in programming, right? So respect the dragon, and you're gonna be fine as programmers. Now, I know fairy tales are amazing and all, but what we wanna see is actually how stuff works really under the hood. So I'm sorry, it's not dragons at this point, but I can promise you, again, another pun intended, that everything is fine. So what are these? These are the event loop phases. Why are they called phases? Well, because they actually happen in a loop way. That is why it's called the event loop, because it goes round and round between those things. So we've got the call stack on one side, which is executed in synchronous context. We've got the heap, which is where the memory is taken to make sure that everything is running smoothly and with the necessary memory that it takes. And then on the other side, we've got the event loop, the fairy, that is taking care of ensuring that all those asynchronous tasks, before running their callbacks and returning it to the call stack and actually running that, it gets to pass through all of this. Now, some of them you actually care about, some others you don't. Like the timers. Timers you definitely care about, because you might need a timeout, you might need an interval, so those are getting collected. The callback is sent for preparation to the thread pools, then gets returned after some point, and it gets on the call stack once more, very simply. We have the pending callbacks, which is when the IO callbacks are deferred to the next loop or iteration. Idle and prepare is only used internally, so do we care? Possibly not. The poll phase, which is when we actually retrieve new IO events and execute those that are the related callbacks. Then we have the check phase, which is when set immediate happens. So set immediate is not running immediately when you call it, which is kind of counterintuitive as a name for a method, but let's leave it at that, right? And then we have the closed callbacks, which is something that we as developers are probably never get to use ever, because we are not, well, Node.js internal developers, most of us. There might be one or two here. I don't know where Marco is. He's the next one talking after me. But wherever he is definitely using them. We're not using them. So that's the thing. We know about some of the intricacies, and what we know is that knowledge is everything in this case. With knowledge comes the real power of the programming nature that we so much love as engineers, right? That is our fairy tale. That is how we love to do things. Be it for performance or knowledge thereof, we just enjoy this as wizards and engineers, right? And so knowing how to use what to use is what empowers us to become really good and excel at the usage of a language. And there are things like process nextstick that you're probably never using day-to-day life. Somebody is. Not a lot of people are, Node.js, for example, but if you learn how to use that, oh, that is real superpower. That gives you power over the entire loop. But with great power, it comes great responsibility, because guess what happens if you don't do well with process nextstick? You block the thread, you destroy everything. That's the only power that you really don't want to use if you don't know how to use it, right? And then we've got set immediate, which again, counterintuitively, is not immediately run. So know exactly when to run it, and if you know your event phases, you know when that is going to run, and you know where it might get stuck. And set timeouts, as we were talking at the start. You might intuitively think, okay, if I'm setting a timer with a 1 second, with 1,000 milliseconds time set, I would expect after 1,000 milliseconds that the callback is run, which is truly not, because the promise that JavaScript, well, any JavaScript engine makes to us is that they can tell us, okay, 1,000 milliseconds, sure, that's when I'm going to put it on the line. Now, as to when I'm executing it, sure, right. And so trust your language, but never trust your language, especially with timers. And yeah, that's it. What I would like to also tell you is that we were talking before about the heap, the call stack, and the calls. But imagine it if it was a tavern, a bar. Do you really care about all of this? What do you want, really, if you go to a bar? A Coke, a beer, a water, whatever you fancy, right? You want a drink. And so, as long as the meat is what they want, it's knowledge, right? You can make pure gold with it, but it's not completely necessary sometimes. So don't worry too much about getting those phases exactly right at first. Go to the bar, get that drink, whatever that is, enjoy the learning experience, but don't get down about it if it's, the next tick thing is not clicking at the start, because it happens, takes a little bit of time. And again, this is what is happening inside the loop in a more loopy way. The smallest ones, as we've seen, idle, prepare, and close, are smaller for a reason. It's because we really don't care about that. It's internal use. The others we've seen are very important. But what I want you to notice is that it's a loop, but it's kind of a loop, not really a circular one. Because what happens really, and this is something that online is not shown a lot, I'm afraid, is that, sure, we're looping through timers, callbacks, idle, prepare, poll, check, and close. But those things, the next tick and the microtask phases, which I haven't talked about before, are actually running after each of the single bigger main phases. So every time a timer is run, a next tick is run, a microtask is run, we go back, callbacks, next tick, microtask, we go back, blah, 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 so on. And that is how it works. And that is why next tick is really, really immense power, because you're getting here in every phase. And if you mess with that, you gotta be sure of what you're doing, because those callbacks, they're gonna block you. So make sure you do that well. And before we end the talk, I would like to make a game with you. And I don't want you to answer me right now. There are contexts later. I want you to read this, and you can send me an email with the answer about this. You're gonna have my contacts later. And someone, I'm sure lots of you are gonna know the answer to this, someone is gonna win. I'm gonna pick it randomly. And you get a free Open Source Day 2024 t-shirt. Not this one, I'm using it, but a new one. So later you're gonna have my contacts. Make sure to send me the right answer, okay? And I would like to close with the fact that strength is found in the mind, but it is accrued with time. So it doesn't come easy, but it is very simple in its own way. Easy and simple are very different things. Programming languages can be very simple. Programming concepts and paradigms can be very simple, but it takes time to understand them. But once you get it, well, it's at your disposal. You can do lots of magic with it. So, have fun. Give yourself enough time to understand the most bits out of it. Damn, I'm so good with puns today. And yeah, have fun. That's it. I am Lorenzo Pieri. I am the bard that sung this story for you. Yeah, I'm a full stack wizard at Birdie. Schrodinger had brother who co-chief, and you might not know me as 404 answer not found, but those are the places where you can find me. As to Birdie, allow me to thank the company that allowed me to be here today. Birdie, we envision a world in which we can all flourish with confidence as we age, is a tech for good company, and we are reinventing care through technology, enabling older adults to thrive at home. We are currently hiring very strongly, so if you're looking for a new opportunity or you just want to talk about it, you can find me later, or you can check out this wonderful referral link that's right there. It's a full remote opportunity in Tech for Good. We are actually helping people using lots of cool technology, and the salary range is between 65 and 95K, so, just give it a try if you're interested. And as for the friends, I would also like to say thank you to these wonderful people that made Open Source Day possible. We are a non-profit organization called Schrodinger Hat. If you look for the black cat, that's who we are. And yeah, without them, there would be not a lot of fun in open source, I would say. So also a big thank to the community. And if you want to get involved in that, let's talk about that as well. And here is the Schrodinger Hat 1. Would anyone like me to go back to the referral link, by the way? I might have gone too fast on that. Okay. Yeah, so this is a link tree for Schrodinger Hat. And guess what? Who remember what happened at the start? Could I talk very fast? Yeah, it's our friend Jack Smallpouch. He's back with the message. And well, actually two messages that I have to think about. One that is not about JavaScript, really. I would like to have a small mention for Golang threads. So Golang threads are very incredibly small, fast, and performant. So if you're looking for a concurrent language that can do magic with asynchronous programming, and a lot better apparently than JavaScript in quite a few ways for the backend part of it, you should check out Golang, because it doesn't take threads directly from system calls, which takes a lot of memory and processing power. It creates dynamically made threads, which are instantiated on the run, and so it takes like a very small footprint of memory. They're amazing. So if you're looking for that performance boost, that is something you could check out. And those were the news about Go. And also the other news is that the talk is over. Thank you, jsday 2024.
Thank you, Lorenzo. It's
But
always...
thank you.
No, thank you.
No, thank you.
No, thank you.
They just want coffee.
Che risata si è fatta?
Who wants coffee, by the way? I'm really eager for coffee.
Yeah,
it's,
but
it's insane. Right?
Was for a coffee or for a question? For a question.
Coffee questions. Yeah, I can answer all of those. No worries.
We have
Any
time for
questions? Okay.
questions.
Yep, hey. We're neighbors from the kingdom where we don't have an elves, unfortunately, but we really take care about the size. Like, you know, we are macro or micro, so it's important for us. So do in your kingdom, it's still important. What is your size? Do you have preferences for micro tasks or macro tasks? Like, is it still important in the Node.js?
Okay, so you're talking about the JavaScript kingdom at that point, the
course.
browser one. Okay.
Yeah, like with this, with many angles, guys.
Yeah, of course. So, how to say that? It's two different environments, right? They run on the same kind of language, but they run in very different ways. And on one side, you have the browser that has to make kind of a few more calls than the Node.js runtime would have to do, because it's another layer on top of system calls, right? So what is more important? I don't know. Both are very important. How can I answer that question? I'm not sure. Like, can you be more specific? Maybe I can try with that.
Yeah, I mean, in the regular JavaScript, it's really important, like what will be take with the call stack, if it's a macro task or micro task.
Okay.
Yeah, is it important in the Node.js? Because I'm not super familiar.
It
but
is.
I'm curious.
It is. It definitely is. And those things are parallelized in the phases, actually. So you don't have a concept of a micro task or a micro task per se as you would have in the browser, but the same thing is acted upon on the various phases that you have. So like, for example, promises are still a micro task in this instance, but what is happening behind the curtains with I/O operations that a browser is trying to do on behalf of the user, that is happening in those I/O phases that we've seen before. So it's definitely kind of still the same thing, but with a different angle and a few more names, possibly, right? Did that answer your question? Great.
Cool.
Any questions about coffee? How to brew coffee? I can teach you that. I can definitely teach you that.
No more questions, really?
Okay, great.
Yeah, no, that's okay.
Is it about coffee, though? No, not yet. That makes me very sad.
I'm sorry.
No
Is there a way to understand if the threads inside libov are too busy?
Interesting. Okay, there is. And there is also a name for that, which of course my mind is not coming up with right now, but there is. And there is a name. Damn it. Talk about this with coffee with me in 5 minutes. But yes,
Okay.
there definitely is. I'm 100% sure of that. And when that happens, you've got threads overload, and it can run into some, well, you can cause runtime errors at that point. So you definitely want to make sure that your threads are not over encumbered by the tasks that you're sending in. And there is a system, and I'm going to tell you in 5 minutes.
Okay, thank you.
Oh, that's on.
I was just wondering about stuff like read from the file system synchronously, which Node allows as a native API call, but sounds really blocking since it's...
Yeah.
How does that work with the fact that not block the
Okay.
the
So
loop? How does it...
yeah, I guess it's about choices, right? Because the Node.js language is an API, right? It's written with another language, which is written with another language, so on. So at the end of the day, there is something calling something else all the time. And with that comes, again, the great power for the developers to know exactly what they want to call at any point in time in their code. And if you necessarily need to use whatever synchronous method that is allowed by the language, then you have other choices that you can take if you don't want to block the main thread, right? We've talked about the fact that libuv is smart enough to know when to take that asynchronous task and put it in the thread pool and then return the callback and so on, right? But I haven't mentioned worker threads, for example, which is another kind of thing that you can use to ensure that your very natural synchronous task can be run somewhere else willingly at that point. It's not libuv taking care of that, it's you. And as a programmer, then you need to take care of that. Make sense? Okay.
Thanks. Very quick question. Is there any kind of scheduling running in place in the event loop when some tasks are put in the micro task queue?
So let me rephrase that. Is there any way we can schedule
No.
when things are running?
Is it like done by the engine by itself? Like for example, you're running a function and you schedule a set timeout. So
Okay.
it's put in the microtask queue. Then the line after, you call for an I/O asynchronous task, and that is put on the microtask queue. Does the engine kind of understand that maybe one activity has priority, so it kind of does one before the other, so it reschedules the order of the queuing from the queue?
Yes and no. As in, it's really about luck at that point and where the loop is. As in, there is priority in the queue. As we've seen, there are two phases that are exactly about I/O events, for example. So if the callback is input in the queue of that phase, the exact time where the event loop is running through that, yes, then it's going to be added in the call stack before some other set timeouts event. But if they are concurrently running, then we've seen the timers, for example, are the first one to run in the phase. And so that phase is on a concurrent level. So exact same time, the timer is going to run first.
Okay, so basically, it's not always a matter of who comes first in the queue, but also a matter of which kind of task it is.
Yeah, and we're talking about exact time.
Yeah,
Right? So
okay.
it's very peculiar. But yes, that is why the phases exist, right?
Okay, thanks.
Okay.
And thank you, Lorenzo.
Thank you.